In this video we're going to look at how we can solve equations that involve logarithms, or by using logarithms. So 5 to the power of x is equal to 3. So I'm going to start this by taking a log of both sides. So log of 5x is equal to log of 3. And I'm just going to use base 10 here, so that's why I haven't recorded a base. And then I'm going to use the power rule to rewrite this first one as x log 5 is equal to log 3. And then I'm going to divide through by log 5, so that x is equal to log 3 over log 5. And I can evaluate that on my calculator. So I have here log 3 divided by log 5, and I've got my answer 0.683 if I do it to 3 significant figures. Be warned, quite often you're asked to leave your answers as exact. So in this case the exact answer would be log 3 over log 5, because I can't simplify that without rounding. So question 2 here, I'm going to start off with the same approach. So I'm going to take a log of both sides. So log 2 to the power of x plus 3 is equal to log 3 to the power of x minus 1. And I'm going to use the log rule, the power rule again. So I'm going to write this as x plus 3 log 2 equals x minus 1 log 3. So that's x log 2 add 3 log 2 is equal to x log 3 subtract log 3. And then I'm going to, from this point, I'm going to collect terms on one side. So I'm going to collect the x terms on the right and the number terms on the left, just because this negative would then transfer in this direction, which means I've got fewer negatives to deal with. So that would be 3 log 2 add log 3 is equal to x, and I'm just going to factorise this at the same time, so log 3 subtract log 2. So I can divide through by that to find my value of x, and I'm going to do this as a numerical value. So 3 log 2 plus log 3 divided by log of 3 minus log of 2 gives me 7.84 as my solution for x. Now this final one is far more complicated, because I have different bases. I've got base 2 and base x. Well, base x is what I don't want, so I'm going to convert that to base 2, but even that's not entirely straightforward, because it's 2 lots of that. So I'm going to use the power rule to write that as log to the base x of 4, that's 2 squared, and then that is going to be the same as log to the base 2 of 4 over log to the base 2 of x. So if I go back to this side, I can now write this as log to the base 2 of x add log to the base 2 of 4 over log to the base 2 of x is equal to 4. And I'm going to use a substitution here to make this easier. So I'm going to say let y be equal to log to the base 2 of x. So I've now got y plus, and log to the base 2 of 4 I can evaluate, because as 2 to the power of 2 will give me 4, log space 2 of 4 is just 2. So I'm going to rewrite this as 2 now. and I can always evaluate that on my calculator. Let's do that just to show how to do that. So I can use this log button up here if I want to input the base. So log to the base 2 of 4. I can see that is just a value here of 2. Log to the base 2 of x, I've said let be equal to y. So I've got y plus 2 over y equals 4. So now I'm going to multiply through by y. So I get y squared add 2 equals 4y. I'm going to subtract 4y to give me y squared subtract 4y add 2 equals 0. And I'm going to solve this quadratic. So y subtract 2 squared subtract 4 add 2 equals 0. And I'm going to continue with this. So y subtract 2 squared is equal to 2. So y equals 2 plus or minus root 2. But y was equal to log to the base 2 of x. So log to the base 2 of x equals 2 plus or minus root 2. And then I'm going to convert between index and log form to say that 2 to the power of 2 plus or minus root 2 is equal to x. And these are my two solutions for x, which I could evaluate, but I'm going to leave them here as exact forms. So I've got x is equal to 2 to the power of 2 plus root 2, or 2 to the power of 2 subtract root 2.